We are supposed to write this as an augmented matrix. And the hard part is we have an x, we have a y, and we have a z variable. That means I need a column for x, I need a column for y, and I need a column for z, and I need values in all of those spots. So let's go ahead and start with our matrix. I know I'm going to need something that would fit like an x, a y, and a z. You don't have to draw those, but sometimes they're nice to have, because on the first one we have 5 x's, so I can put a 5 to start off. I have 0 y's, 0 z's, but it's going to equal 6. For the next one I have negative 4 x's, I have 0 y's, I have 2 z's, and I have a negative 1 there. And finally I have 4x, 4y, 0 z's, and that's going to equal 7. So that's exactly how your augmented matrix will look. You have to be able to write an augmented matrix, otherwise you can't do that Gaussian elimination. All right, the next one we're supposed to write each as a system of equations. I'm going to do mine a little different than yours, but it's going to be the exact same thing. I did say you can pick whatever variable you want to. Usually you pick x, y, z, but I'm just going to go ahead and say, well, I'm going to make this my A, B, and C columns. So if that was the case, this top row would be 1a plus 3b plus 0c equals 5. My bottom one would be 1b minus 4c equals 8. And my other one would be negative 2a plus 5c equals 7. Obviously, you could have x's and y's, so this would be x plus 3y. This would be y minus 4z, and this would be negative 2x plus 5z. But just recognize that variables are things that you pick. It's just as mathematicians, math books, we usually pick x, y, z to fill in these spots. But at any given time, I can make them A, B, and C, and you have to translate it in and out of augmented matrices. All right, questions on that? These will most likely be on the test. Once again, they should hopefully be easy problems, putting it as an augmented matrix or just going the other direction. All right, what questions do we have from the homework? All right, solve that problem. All right, then let's go on to just today's lesson. Today's lessons will basically, if you had a question on how to solve augmented matrices using Gaussian elimination, this is a super complicated problem that has all those elements in it. So you should be able to see something and stop me if you're confused about something. So we're supposed to use Gauss-Jordan elimination. Sometimes it's just called Gauss elimination, or sometimes it's just called Gaussian elimination. Anytime you see Gauss and elimination, you're using matrices in this manner. So really the key word is this Gaussian. All right, the first step to Gaussian elimination is to first put it in as an augmented matrix. So we're going to write this in the first kind of matrix I already gave you. We're going to put it as an augmented matrix where we're going to have 2x, 2y, 2z, and that's going to equal 6. Our next one would be 4x, 6y, 14z equals 0. And finally, we're going to have 1x, 3y, negative 2z, and 17. Just so you know, we're not going to do it here, but you can make your life a little easier sometimes. See how this is 2x plus 2y plus 2z equals 6? You can start off by dividing both sides by 2 and make it easier. We're going to do it. It's going to happen anyway. So you don't have to erase anything yet, but we're going to make that happen in just a second. Because with Gaussian elimination, I'm going to go ahead and go to my next slide, which already is there. With Gaussian elimination, we work from left to right, column-wise. So I need to get this column done first before I move on. And remember, we're trying to make all 3 of these be the identity matrix. And remember, the identity matrix looks something like this with a 3 by 3, where we'd have that. That's our whole goal, is to turn this into that. When we're working from column to column, we start by finding the value that needs to be 1. And then we find the ones that need to be 0. So the one that needs to be 1 is this 2? There's actually a couple ways to do this. We're going to do it kind of the primary way, and that is to multiply that entire row by its reciprocal. So to make 2 into 1, you multiply it by 1 over 2. If this was a 3, I'd multiply it by 1 over 3. If this was a 7, I'd multiply it by 1 over 7. Whatever the reciprocal is, that will make it 1. So in this step, we're just going to take 1 over 2 times row 1 is going to become my new row 1. Well, that's going to leave me with 1, 1, 1, 3. I didn't change anything else, so I still have 4, 6, 14, 0. I have 1, 3, negative 2, 17. Now, this would have been the exact same answer if you would have divided this first thing by 2 on both sides. I would have had 1x plus 1y plus 1z equals 3. Let's backtrack real quick. I'm looking back here and I'm pretending I didn't do this step. Can anyone look at this first matrix and tell me another way I could have created 1 using those 3 possible ways to adjust matrices, how I could put a 1 up here? Natasha?
Didn't you do like R3 replace R1?
Yeah, we could just flip the 2 things. You could just do replace R3 and R1, flip them, and you would have a 1 there. That is 100% allowed. You just need to get a 1 up there, and it has to be following those rules that you can flip, you can multiply an entire row, or you can multiply a row and add it to another row. So another method might be multiplying row 3 by negative 1 and adding it to row 1. I probably wouldn't do that. That's a lot of work when you could have just flipped it or multiplied by 1/2. So there are multiple ways to get a 1 in that position. All right, let's go ahead and move on. So right now I have 1, 1, 3, 4, 6, 14, 0, 1, 3, negative 2, 17. As soon as your 1 is in your column, your next step is to make everything else in that column 0. So I need to make this 4 and this 1 0. And in fact, we're going to do it all in the same step. But let's focus on the 4 right off the bat. So I'm going to circle that 4. I need to change that 4 to a 0. The easiest way to do that is to take your freshly created 1, that thing that's in the top left. And what you're going to do is you're going to multiply that row by the opposite of 4, which is going to be negative 4. So once again, take that 1 you just created, multiply that entire row by the opposite of 4, which is negative 4, and then add it to row 2. So it's going to look something like this when we're explaining it. We're going to say, well, take negative 4, multiply it by row 1, add it to row 2, and that's going to become my new row 2. So in effect, what I'm actually kind of doing is I'm kind of pretending none of this exists around it. And all I have is that fresh 1 and that 4. And I'm asking myself, what do I multiply 1 by? So when I add it to 4, it becomes 0. Well, that's negative 4. First of all, I'm not changing anything in the first row, because that's going to stay 1, 1, 1, 3. Our next row is multiply row 1 by negative 4. So you have negative 4 times 1, which is negative 4, plus 4 is going to give me 0 in that new spot. Then we're going to have negative 4 times 1 is negative 4, plus 6 is going to be a positive 2. Finally, we're going to take that negative 4 times that 1, which will become negative 4, plus 14 is going to become 10. And that last one is negative 4 times 3 is negative 12, plus 0 is still a negative 12. In that same step, we're now going to turn that 1, using that exact same method, turn that 1 into a 0. Now all I care about is that freshly minted 1 I have. What do I need to multiply that by so when I add it here it becomes 0? Well, it's the opposite of this. So this time I'm going to do a negative 1 times row 1 plus row 3 is going to become my new row 3. So we go through that whole process again. Yeah, Mary?
Sorry, can you explain what you did the negative 12 again?
I did negative 4 times the 3 is negative 12 plus 0 is negative 12. That's okay. Yeah. All right, but we're going to do the same process. We're going to do negative 1 times 1 is negative 1 plus 1 is 0. Negative 1 times 1 is negative 1 plus 3 is 2. Negative 1 times the negative 1 plus a negative 2 is a negative 3. And finally, we have negative 1 times that 3 is negative 3 plus 17 is going to leave us with 14. That's one column. One column, no matter how big this is, should happen in 2 steps. It should be you change whatever one needs to be 1 first, and then you change every other row to 0. Then we're on the next column. Once again, we're going to locate which one needs to become 1. Always find your 1 first. It is your first step is 1. First step is 1. So we need to make that middle 2 a 1. Now everyone look up here really quick. Why would it be a terrible idea to just switch these 2 to put a 1 there? Mary? Because then you have to start all over again by getting a 1 up there. So the only time you're ever going to switch to get a 1 is the very first step. Otherwise, you're just going to always just follow these steps. So now to make that into 1, we're going to multiply by the reciprocal of the number I circled, which is just 1/2. It turns out it's 1/2 again. It's not always 1/2. If that was a 3 there, it would be 1/3. So we're going to multiply that entire row by 1/2. And it's going to become my new row 2. So the only row I changed was row 2. So row 1 is going to stay the same. That's 1, 1, 1, 3. Row 2 is going to be 1/2 times 0 is still 0. 1/2 times 2 is 1. 1/2 times 10 is 5. 1/2 of negative 12 is negative 6. And row 3 stays the same as 0, those, negative 3, and 14. As soon as you find that 1 and you turn it into 1, your next step is to turn the rest in that column into zeros. So that means that top 1 needs to be a 0, and that bottom 2 needs to be a 0. So let's first circle that top 1. Just remember, the one I just created is here. This is the one you're using. So we're going to multiply row 2 by a negative 1. Negative 1 times row 2 plus row 1 is going to replace row 1. So I just had the opposite of 1 is negative 1. Multiply it by the row you just created the 1 in. This should force this to being a 0. And let's check that out. All right, negative 1 times 0 is 0, plus 1 is still 1. That should hopefully never change unless you made a mistake. Negative 1 times 1 is negative 1, plus 1 is 0. Negative 1 times 5 is negative 5, plus 1 is a negative 4. And finally, we have negative 1 times a negative 6 makes it a positive 6, plus 3 is a positive 9. I didn't change row 2 because that already had the 1 that I already changed, so we'll have 0, 1, 5, negative 6. The last thing we need to change is that 2. That bottom 2 needs to become a 0. To make it a 0, you're just going to multiply by the opposite of 2, which is negative 2. And you're going to multiply that by the row that you just created that 1 in. So I'm going to do negative 2. Let's go back to black. Negative 2 times row 2 plus row 3 is going to become my new row 3. So the first step we're going to have is negative 2 times 0, which is 0 plus 0 is still 0. That's a lot of zeros. Then we have negative 2 times 1, which is negative 2. Plus that 2 is 0. Then we have that negative 2 times that 5, which is negative 10, minus 3, which is going to be negative 13. And then finally, we're going to have negative 2 times negative 6, which is going to be a positive 12. And 12 plus 14 equals 26. Your job is to finish this. Your job right now is to finish this. Remember the steps. Your first step in this column is to locate which one needs to be 1. Use its reciprocal to create that 1. Yes, Mark?
Negative 12 plus 14 is 2.
Which one's wrong?
You said it's 4 to 6.
Oh, it's negative 2 times a negative 6, which is a positive 12.
Oh, right.
Positive 12 plus 14 does equal 26. So locate which one needs to become a 1. Make it a 1 by multiplying by its reciprocal. Make sure it's a positive 1 because right now it's negative. Then locate the other 2 and make them 0. Ask questions if you are stuck. I'll give you about 5 minutes. That's about all I can give you. So that's going to leave me with 1, 0, negative 4, 9er, 0, 1, 5, negative 6. I would have 0, 0, 1, and 26 divided by negative 13 is going to be a negative 2. Good news is I now know that z equals negative 2. That whole row is done, so z equals negative 2. To get the rest of them, I'm going to make everything else in that column equal to 0. So I'm going to start with that negative 4. Now the opposite of negative 4 is a positive 4. So I'm going to take positive 4 times row 3 because that's the one I just created that 1 in. So I have 4 times row 3 plus row 1 is going to become my new row 1. And hopefully that will create that 0 I want. Well, we have 4 times 0 plus 1 is still 1. 4 times 0 plus 0 is still 0. And then finally we have 4 times 1, which is 4, plus negative 4 is 0. Now to get what that equals, we do 4 times a negative 2, which a lot of us missed is negative 8, not positive 8. It is negative 8 plus 9 is going to be just 1. And we're going to do the same thing for row 2. I need to get rid of that 5. The opposite of 5 is a negative 5. In other words, negative 5 times 1 plus 5 is going to be 0. So we have negative 5 times row 3 plus row 2 is going to become my new row 2. Well, that means the 0 is going to stay. We have negative 5 times this 0 plus 1 is still 1. We have negative 5 times 1 is negative 5 plus 5 is 0. And finally, we have negative 5 times a negative 2 becomes a positive 10. Minus 6 is going to be 4. And row 3 is already done, so we have 0, 0, 1, negative 2. It's always a good idea to end this with like x equals 1, y equals 4, and z equals negative 2, so you understand that they are variables that go back into the equation. Mary?
How do you know whether, so like the second to last like option, how do you know these are 3 as opposed to odd 1?
Because we always use the 1 that we created.
Oh.
So we changed negative 13 to 1. And why we specifically picked this is because we know it's not going to affect anything else later on. If you pick anything else and you try to use that, you're going to start muddling up the zeros and ones you already got before it. So it is always create a 1 and then use that row to multiply by to add to the other ones. Okay, so if you notice when we started off here, I changed this 2 to a 1. So that must mean every case below it, I am multiplying by row 1. And I look down and, yep, it's negative 4 times row 1, negative 1 times row 1. Same thing here. I changed this 2 to a 1. So that means over here, I'm going to be using row 2 as the tool to get rid of those. So it is always the one you created. That row is the one you're going to use to add to the other rows. Does that clarify of sorts?
Yeah.
Okay, yep. If you do anything else, you're going to start messing with the ones and zeros you already created. All right, other questions? It's a big set of steps, but they're the same as a normal x, y. We just add another variable into it, so it's a little more tricky, and you are going to make mistakes on these. It's just going to happen because you're basically forced to do a whole bunch of math in your head. It would take too long to write out every one of these math things to make sure it's right, so a lot of this just happens in your head. All right, a couple more examples, and these are special cases. We have dependent systems. Remember, a dependent system is one in which has infinite solutions. Well, that must mean that this one has infinite solutions, but let's see what it looks like if I'm using Gaussian elimination while solving. How do I know it's a dependent system? So let's go ahead and use Gaussian elimination. So that means I am going to create a table where we have 2, 1, 4, and 4, 2, 8 on that bottom row. So now I have an augmented matrix. Now I can use Gaussian elimination. Gaussian elimination says work from left to right. Find your 1 first. Well, to be the identity, these both need to be 1, so I know this top left one needs to become a 1. So I'm going to circle that, and I'm going to say, well, the easiest way to turn 2 into a 1 is to multiply by its reciprocal. So I'm going to multiply the entire row 1 by 1/2, and that will become my new row 1. 2 times 1/2 is 1. 1 times 1/2 is 1/2. 4 times 1/2 is 2, and I did nothing to row 3, so that's still 4, 2, 8. My next step is to create a 0 in that column. That 4 needs to become a 0. So I'm going to go ahead and circle that 4. And I'm going to use that 1 I just created, whether it's here or if it's 3 by 3, you always use the 1 you created to get rid of that 4. So that means I'm going to multiply row 1 by -4. And I'm going to add it to row 2, and it's going to become my new row 2. Well, -4 times 1 plus 4 is 0. Maybe I should come over here and actually write it down instead of picturing it in my head. So we have 0. -4 times 1/2 is -2 plus 2 is a 0. And finally, we have -4 times 2 is -8 plus 8 is 0. I did nothing to my first row, so that's still 1, 1/2, and 2. If you try to keep going further and trying to turn this into your identity function, it wouldn't work. There's no way to turn 0 back into a 1. You have to multiply by the reciprocal, and I'm telling you right now, 0 times 1 over 0 does not equal 1. There is nothing further you have to do. You are done. Because remember what this is. This is an equation. This is a specific equation that says, well, 0x plus 0y equals 0. In other words, 0 equals 0. This is a case where your variables drop out and you have a true statement. It is true, and that makes it dependent. So if your variables drop out and it comes to being a true statement, it is dependent.
Wait, what about the other one?
What other one?
The one above it, R1. That's
I don't have to care about it.
Oh.
I know it's dependent, so I can put any x and y values in, and it'll work. In other words, because this is true, these are actually either parallel. I mean, not they're parallel. They're actually the same line. If you would change this stuff around, you would come up with the exact same line. In fact, if I divided all this by 2, we'd end up with 2x plus y equals 4. It's the exact same thing. So you don't have to worry about the first row. As soon as you see this, you're just like true, so it's dependent. You don't have to worry about it. All right, the next case of dependent systems is this one. If I was going to write this as an augmented matrix, it would look like this. I would have 1, -1, 1, and 2. I would have -2, 1, 2, and 5. Here's a problem. There's no way to really write it as an identity. We can do our best, and we'll see what it looks like in just a second. But at best, we can make these ones and these 2 zeros, which isn't going to get us an answer. We can try it and see what it looks like. Let's go ahead and do it. So the first step when we're using Gaussian elimination is locate your 1 in your first column. It's already done, so I don't have to do that. The next thing I have to do is create a 0 for all the rest of them in that column, so I need to turn that -2 into a 0. So that's going to happen by multiplying row 1 by 2. We're going to add that to row 2, and it's going to become my new row 2. All right, row 1 didn't change, so we still have 1, -1, 1, 2. On the bottom, we're going to have 2 times 1 is 2, plus a -2 is 0. 2 times a -1 is -2. Plus 1 is a -1. And finally, we have 2 times 1 is 2, plus 2 is 4. 2 times 2 is 4, plus 5 is 9. Next thing I have to do is move to the next column. Next column, I need to find which one needs to be a +1. And that's that -1 there. Well, to turn a -1 into a +1, just multiply everything by a -1. So I'm going to multiply that entire row by -1. So -1 times row 2 is going to become my new row 2.
Wouldn't it just be a positive one? Oh, I'm sorry.
Okay. So continuing on, we are going to have the first row is going to stay the same. 1, -1, 1, 2. Bottom row is just going to be negatives. So 0 is still 0. Then we have a +1, a -4, and a -9. Last thing I need to do is I need to turn that -1 into a 0. Oh my God, I'm going to do that right below it. So we're just going to basically add row 2 to row 1. Row 2 plus row 1 is going to become my new row 1. And that's going to give me 1. 1 plus a -1 is 0. -4 plus 1 is a -3. -9 plus 2 is a -7. And we're done here. We have 1, -4, -9. Now what we really have here is x minus 3z equals a -7. And we also have y minus 4z equals a negative 9. That's as far as we can go. That means z can be any value you want it to be. If z is 2, it works for all of it. If it's 3, it works for all of it. And here's the big problem here. How many variables do we have? We have 3 variables. How many equations do you need to solve 3 variables?
3.
You need 3 equations. So if you ever get down to here, you will just know it's a dependent. It is unlimited answers unless I have a third equation to lock down what z needs to be. Who wants to see a shortcut on this one? Yeah.
Why did you do all that? Couldn't you just say those things?
Couldn't I just, yeah.
Instead of 3 answers.
Yeah, that's what I'm going to say right now. What we should have actually done, and it's something you are allowed to do, is you could have recognized that the true way to write this would have been writing it as 1, negative 1, 1, 2, negative 2, 1, 2, 5. And my third equation would be 0, 0, 0, 0, because I don't have one. It's just all zeros, which means it falls into category number 1 where 0 equals 0. Or you could just say what Emma said, I need another system. You should at least try, because there are times when you have 3 variables and 2 equations that these will turn to zeros. All right, there are times. So you should try it and see if it's going to end there or not. All right, so those are our 2 dependent systems. Yeah, Mary?
Alright, so if you have one less equation and it's like for here you have 2, for here you have 3 to figure it out.
Mm-hmm.
Is it always like that where it becomes dependent? Like if you have 3 equations and you get 4, is that also dependent?
If you have 3 variables and you have 4 equations, say that again? You sure? I would just double check. I would do this method really, really quick, or I would do a test. 99% of the time, it's just going to be dependent automatically. But there are cases where you end up here where your 2 z's are zeros, that they just cancel each other out. All right, the last thing we're going to talk about is inconsistent. Inconsistent system. Before I put in an augmented matrix, the first thing you have to do is make sure your variables are lined up. So I'm going to rewrite this as x minus y equals 3. And I'm going to write this as negative 2x plus 2y equals 5. Your variables need to be lined up on the same side. They all need to be on the left, and your constants need to be on the right. You're going to forget this. All right. Prove me wrong. So we are going to have augmented matrix 1, negative 1, 3. We're going to have negative 2, 2, and 5. When I'm solving an augmented matrix using Gaussian elimination, the first thing I do is work left to right. So I start with that 1 and negative 2. I locate which one needs to be 1. It's already 1. So my next step is to make everything else in that column 0. So I need to make that negative 2 a 0. So we're going to multiply by the opposite of negative 2, which is a positive 2. Multiply that by row 1, add it to row 2, and it's going to become my new row 2. Doing that multiplication, we'll have 2 times 1 is 2, minus 2 is 0. I guess I should do this not in my head, but on the sheet, so that's going to be 0. 2 times a negative 1 is negative 2. Plus 2 is 0 again. That's always an issue. And we have 2 times 3 is 6, plus 5 is 11. And my first row remains 1, negative 1 trace. Anytime you have those double zeros, it's always something special. In this case, we would have 0x plus 0y equals 11. In other words, 0 equals 11. That is false or not true. So it is inconsistent. All right, guys, for the homework, you have a bunch of those to work on, particularly like number 33. It can be helpful to try to eliminate those decimals first. It's sometimes really hard to use decimals in those. So you can use regular math to get rid of them. Also, how I solve it might not necessarily be exactly how you solve it. I might switch rows because I know it's going to work or something like that. We just have to have the same answer. All right, guys, have a wonderful Wednesday.